a pleasure to be here. Today, I would like to tell you about the work we at Google are doing on using machine learning to keep our users healthier and safer. Just because I work for a major corporation, I have to make a few disclaimers. All the opinions here are solely mine, all the mistakes are mine, and the technologies I might be talking about might or might not be in actual use. So with this, we've been working on health search for a couple of years now, and over this time, we have been building new experiences for consumers who use Google search every day. The latest addition to this family is Symptom Search, I show here on the left-hand side. What Symptom Search allows users to do is to come to Google as they normally would and formulate queries with their symptoms. In this example, it's headache over one eye and nausea. And when we recognize the user is entering a list of symptoms, we would show them a horizontal list, a carousel of conditions which are medically appropriate for the input query for this list of conditions. With the addition of Symptom Search, we have actually closed the loop on our health offerings in search, because users can come to us, search for symptoms, we'll tell them what they might have, then they can click on one of the conditions and learn more about it. The way we allow them to learn more is we show them what we call a knowledge panel, a structured information about the disease, its prevalence, its breakdown over ages and genders, and more information about symptoms, how the disease often manifests itself, and treatments. And then users can click on the treatments tab and learn about typical treatments. Some would require a prescription, some would be over the counter. So in the remainder of this talk, I would like to tell you more about how the distribution of queries in Symptom Search looks like, what challenges we encountered, and how we overcame those. But first, let me tell you a story. And it's a story I read at the end of last year, actually when preparing a different talk. I wanted to see just how useful our stuff is. And it's a story about a patient who underwent foot surgery and was discharged from a hospital and was having pain. So one day his wife decided to drag him to a doctor, and the guy is a stoic type, he doesn't complain much. The doctor looked at him, examined him quickly and said, okay, you're fine, go home. And it was obvious to him and his wife that it's not really okay. So before leaving the premises, his wife took a cell phone from her purse and typed a query such as this one, calf pain after foot surgery. And we usually show up to 5 conditions we believe to be medically appropriate. Of those 5, 3 were indicating various versions of blood clot. And blood clot is a serious thing. You can lose your leg, you can lose your life, and they were justifiably alarmed. So the wife is dragging her husband back to the doctor's office and says, here is what Dr. Google believes my husband has. And you can imagine what the human doctor's reaction was, right? Who are you? And you're using Dr. what? But still, he was kind enough to examine the patient again. He prescribed some tests. And long story short, it was a blood clot. And we have developed a technology that allowed to catch a condition that the human attending doctor has missed. And the moment I read this story, it made my day, it made my year. What we are doing is real, and we are saving lives. So let me show how we are doing this. So first, let me tell you a bit about the distribution of queries we are seeing. So of the entire query volume we see at Google, and of all the queries that hit Google search every second, 5% are health. 5% of all the query stream at Google is a huge number. Okay? Let's see what kinds of queries we are getting at health. Some of them are very simple. They are wellness queries, how do I become fit? There might be searches for health-related news, or fitness courses, or navigation in the real or the virtual world, like Good Samaritan Hospital. It's a navigational query. In this case, it's a hospital where my kids were born. Then there is a big chunk of medical queries, which we define as queries which normally require an MD to consult. Conditions, treatments, symptoms all belong to this set. We are looking at symptom queries, of which there are 1%, again, of the entire Google query stream, 1% are symptom queries. And we are looking at the intersection of symptom and condition-seeking queries. Those are queries when users come to us with a list of symptoms and they would like to understand what conditions they might have. Again, our input is symptoms. We would like to map them to medically appropriate conditions. So why is this problem hard? It's hard for a variety of reasons. First of all, there is a lexicon mismatch between the language doctors use and the language we, patients or users, are using. For example, when my kid had nosebleeds, often I would take him to a doctor. I would say, hey, Dr. Lee, my son has a nosebleed. And the doctor would meticulously write epistaxis in his medical record. We complain about skin reddening and doctors write erythema. We complain about difficulty breathing and doctors write dyspnea. And there is a large divide between the ways users formulate their questions and the way doctors talk about them. And users could use arbitrarily colloquial language, for example, yellow gunk in my eye, something a doctor would never say, right? He would describe this in medical terminology. And that's why we critically rely on machine learning, because there are infinite number of ways users can formulate their questions, and we need to anticipate those, and we need to recognize them, classify them in real time to answer. And finally, the user intent behind the queries is very elusive. Think of a query as common as weight loss. It could be a query about how to lose weight and how to find a product for losing weight. It could be a symptom you are experiencing, a precursor of a disease, or it could be a side effect of a drug you are taking. So with this simple one-slide overview, let me walk slowly through how Symptom Search works. Again, it starts with a query which hits Google search. In this example, it's cough at night in children. We would, of course, show you Google search results. In addition, on top of the results, if appropriate, we show you a list of conditions which are appropriate for those symptoms. So the users came to Google, they expect search results, and we would compute search results anyway. We use what's in information retrieval research called pseudo-relevance feedback assumption. We assume the top results returned by Google to be relevant, and we would extract some conditions mentioned in those pages. And you know, Google has been working on search for close to 18 years now, and Google search works pretty darn well. So one source of conditions we get by taking a symptom query, running it through Google search. Another source of candidate conditions we get is by consulting our health knowledge graph. We constructed the health knowledge graph by meticulously searching the internet, crawling the internet, constructing a large repository of medical facts, and then painstakingly validating every single extracted fact with doctors. So it's supposed to be quite comprehensive and highly accurate. We get one set of conditions from Google search. We get another set of conditions by identifying symptoms in the query, consulting the knowledge graph. We pull together the two resulting set of conditions, and then we build a machine learned ranker to order the conditions in the decreasing order of their relevance. And here we again consult the knowledge graph to get a bunch of related features, for example, prevalence of different diseases. Let me show you why it's actually important to rely on search results. So suppose my query is as cryptic as this. If you are sitting in the last row, it's 155 space 90. Any ideas what this query might mean? 155.90, what could it mean? It could mean blood pressure. Any other ideas? Okay, so you are typical Google users. Great. What our users taught us by reinforcing what they like to see with clicks is the top 10 results Google shows for this query are all highly relevant to what you wanted to see, blood pressure, right? It is not the only possible interpretation of this query. And here I did an image search. It could be a car tire, it could be a cell phone case, or on the far right bottom there is my favorite, it's actually a tank. It's artillery systems for the 90s, gun equipment 155 millimeters caliber. So 155.90 could mean a gazillion of things. Our users have taught us by clicking what they like, that it is a blood pressure interpretation they like. It is sometimes working well, sometimes it is working less well, and I'll be talking about cyberchondria later today. But for now, let's see that using search results is actually good. And let's talk about consulting the knowledge graph. So suppose our query is knee pain when squatting down, something I experienced last year, and here is a relevant portion of the knowledge graph. So the health knowledge graph is huge, contains thousands of medical concepts. Here is a relevant portion of the knowledge graph, and it has relevant diseases, conditions, treatments, and possible causes. So what we do is every time we recognize a symptom mentioned in the query, in this case knee pain, we look up in the health knowledge graph and we fetch the relevant condition, in this case patellar tendinitis, and we add it to the pool of conditions we will be ranking for the user input. So let's juxtapose the knowledge graph, structured repository of knowledge, and web search. So knowledge graph is highly medically sound. We verified every single fact with doctors. We are striving for it to be comprehensive. It's always imperfect, in particular because users can use all kinds of informal or colloquial language, and we might be lacking those colloquial terms. On the other hand, medical web search or web search in general possesses completely different properties. It's very comprehensive, well, as comprehensive as web crawl is. However, it's subject to what we call content bias. Well, you know, not every page found on Google is of equally high quality, so it's as good as writers make their stuff to be good. Sometimes things on the web are difficult to interpret, and there is cyberchondria. Just curious, how many people in this audience know what cyberchondria is? One. Just one? Okay, so you'll actually learn something new today. Cyberchondria happens when you come to Google with a benign query, headache, minor pimple, and then you see something frightening or very frightening, and the next 5 hours you think you are dying from cancer now, and you're researching it. Okay? And that's when relying on users' clicks is actually not so good, because users teach us, well, not necessarily medically appropriate facts. So here is an example how it happens. You come to Google and you search for leg pain in children. Something very benign. It could have a million of benign explanations. Well, Google's been Google. It shows you query formulations, right? You hit space, you get query suggestions. The first one is leg pain in children cancer. Why it happens? Because unsuspecting parents come to Google, they see cancer mentioned somewhere in small font at the bottom of the page. My child must be having it, right? And the next hours they search for it and reinforcing Cancer Week's clicks. If you think it only applies to Google, no. It also happens on Bing. If you search for leg pain in children on Bing, you get something slightly different. The next reformulation is leg pain in children leukemia. Okay? So we need to work with this, right? We need to alleviate users' concerns. So let's see how we are doing it. So users are coming to us to search, and let's say they issue a query like this, headache. The first thing they really want to know is this scary, and am I going to die? And in some cases, you really are having a serious disease. You might be having a heart attack sometimes. But in many cases, you are not, and we want to calm you down. So we do two things. First, we show you a card, which we really call a calm down card, and we tell you, well, you know what, headache might not be necessarily due to an underlying disease. Maybe you got too stressed. Maybe you need to change your eyeglass prescription, or maybe you are just wearing headwear which is too tight. The second thing we are doing is when we are getting a single symptom query, a query containing one symptom, like headache here, it's a rare luxury. We usually have queries with 2, 3 or more symptoms, but when we have a single symptom query, we have asked doctors to exactly enumerate a list of conditions in the correct order of medical relevance. We are 100% certain in the quality of this. Again, it's a rare luxury we have. In the majority of cases, we have too many symptoms in the query. We could not have anticipated them. That's why we rely on machine learning. However, whenever possible, we offer this. For single symptoms, we just show exact list of relevant medical conditions, and you will not see brain tumor for a simple headache query. How do we evaluate our approach? There are multiple ways which we can use to evaluate our system. We use real doctors. And we ask them a simple question. If you saw a patient with this constellation of symptoms, would you be comfortable to show them a list of conditions that Google has computed? There are multiple other metrics you can use. what conditions are missing, what is the usefulness of individual conditions. However, we ask them for approval for the entire set. Would you be comfortable with showing this list of conditions? And we have worked very hard to keep our approval rate at 90% for US English, and we have recently launched Symptom Search in Brazil in the Portuguese language, and the approval rate is even higher, 94%. So it's working pretty well. Finally, the previous speakers in the panel talked about explainability or reasoning behind the model, and how do we explain to users what's actually going on. So one of the first changes we have made to our approach, one of the first updates to Symptom Search, was to explain our decisions. And here we again rely on the health knowledge graph. We take symptoms from the query, we look them up in the knowledge graph, and we fetch the associations between conditions and symptoms. Then when we show the condition cards, we highlight the symptoms the user was searching for or synonyms of those symptoms to help users explain what we are doing and why we are recommending those. So let me quickly conclude this talk. Again, of the entire search volume of queries, 5% are about health, about 1% are about symptoms. It's a huge number of cases users rely on us. They expect us to help them address their health concerns, and we are there for them. We use machine learning extensively. We're using it to classify queries, to determine if the query is medical, if it's seeking for symptoms, and if users are trying to figure out what condition they might have. We're using machine learning to rank conditions in the medically appropriate order for their symptoms. And finally, well, we hope one day we'll use machine learning to cure. We use the health knowledge graph in order to better understand, better map symptoms to conditions, better rank conditions, and better explain conditions. And finally, for evaluation, we're using real doctors. And just a friendly piece of advice, if you're doing a domain-specific search or domain-specific application, you should befriend domain experts, which in our case are medical doctors. Thank you very much.